We have so far learned how to find the lengths of horizontal lines, vertical lines, and diagonal line segments. In this video, we will learn how to find the gradient of a straight line. You have learned that the gradient of a straight line refers to the steepness of the slope. Given this hill, and if you would like to determine the gradient of the slope of this hill, we can use the idea of rise over run. The rise is denoted by the vertical distance of the slope and the run is denoted by the horizontal distance of the slope. The ratio of rise over run gives us the gradient of a slope. In this video, we will explore further how we may derive the gradient of a straight line in a Cartesian plane. Do you know that we can tell whether the gradient of a straight line is positive or negative just by looking at how the y value changes as a point on the line moves from left to right? For this line, when a point moves from left to right, the y value of the line increases from 1 to 3. Hence, the gradient is positive. Let us take a look at another line. When a point moves from left to right, the y value of the line decreases from 3 to 1. Hence, the gradient is negative. We shall now use the idea of rise over run to find the gradient of this straight line. To find the rise and run, we will draw a vertical line down from the point 2, 3 and a horizontal line from -3, -1 until they meet at a point. We will see that a right-angled triangle is formed. We will also see that the coordinates of this point are 2, -1. It is important to note that the vertical line represents the rise and the horizontal line represents the run. The rise is given by the length of the vertical line, which is 3 minus -1, which gives us 4 units. The run is given by the length of the horizontal line, which is 2 minus -3, which gives us 5 units. Since the value of y increases from left to right, the gradient of the slope is positive. Thus, the gradient of the straight line is given by the ratio of the rise over the run, which gives us 4 over 5, or 0.8. Next, let's try to find the gradient of this line using rise over run. To find the rise and run, we will draw a vertical line down from the point -3, 2, and a horizontal line from 3, -1 until they meet at a point. Again, we will see that a right-angled triangle is formed and that the coordinates of this point are -3, -1. We know that the vertical line represents the rise and the horizontal line represents the run. The rise is given by the length of the vertical line, which is 2 minus -1, which gives us 3 units. The run is given by the length of the horizontal line, which is 3 minus -3, which gives us 6 units. Since the value of y decreases from left to right, the gradient of the slope is negative. Thus, the gradient of the straight line is given by the negative ratio of the rise over the run, which gives us -3 over 6, which is equal to -0.5 or -0.5. We will now find a way to generalize a formula to help us find the gradient of a straight line. Consider this straight line with the two endpoints denoted as x1, y1, and x2, y2. Let us draw a vertical line from point B and a horizontal line from point A. Point C is the right angle and the coordinates are x2, y1. Now, what is the gradient of the straight line AB? We know that the gradient of a straight line equals the rise over the run. Let us now take reference from the previous example. The rise was given by the difference of the y coordinates 3 and -1. Thus, the rise or length of BC is given by y2 minus y1. Similarly, in the previous example, the run was given by the difference of the x coordinates 2 and -3. Thus, the run or length of AC is given by x2 minus x1. Hence, The gradient of a straight line is equal to rise over run, which can be written as y2 minus y1 over x2 minus x1. Let us take a look at one example where we can apply what we have learned. A, -5, 6, and B, 4, 10 are points on a coordinate plane. Find the gradient of AB. Again, it is always good practice to make a quick sketch of the information on a coordinate plane to see how the line segment actually might look like. What is interesting is that you should realize from the sketch that the gradient of the straight line is positive as the value of y increases from left to right. So, you should expect that your answer is a positive value. If it is not, you might want to revisit your calculation or revisit your sketch. This is a good and effective way to reflect and check on your work. Now, to find the gradient of AB. It is given by y2 minus y1 over x2 minus x1. As a good practice, we should label the coordinates to help us apply the formula more efficiently. For point A, -5, 6, we label -5 as x1 and 6 as y1. For point B, 4, 10, we label 4 as x2 and 10 as y2. Hence, the gradient AB equals 10 minus 6 over 4 minus -5, which gives us 4 over 9. The calculated gradient is positive, and this is expected from our sketch.